Simple question. You've heard it before. Someone says if you travel fast enough, you age slower. Maybe you've seen it in a movie. Maybe someone explained it to you once and you nodded along. But do you actually know why? Not the Hollywood version, not the hand-wavy Einstein said so version. The real version. The version that when you actually understand it, makes you sit back and stare at the ceiling for a while. Because the answer is not what you think. It is not that space does something strange to your body. It is not radiation or zero gravity or some exotic effect that only happens far from Earth. It is something far more fundamental, far more unsettling. It is about what time actually is. Start with something simple. You are sitting in a chair right now, completely still, not moving, except you are moving. Right now, sitting perfectly still, you are hurtling through space at roughly 30 kilometers per second because Earth is orbiting the Sun. The Sun itself is moving around the center of the Milky Way at about 230 kilometers per second. The galaxy is moving through the universe at hundreds of kilometers per second more. You are never still, not for a single moment in your entire life. But here's the thing, none of that motion is what we are talking about. Because in physics, motion is relative. There is no fixed background against which to measure speed. You can only ask how fast something moves relative to something else. So forget the galaxy, forget the solar system. Let's get simple. Imagine you and a friend, empty space, nothing else. You are moving apart from each other at, say, half the speed of light. Who is moving? You might say you are both moving. Or you might say you are still and your friend is moving. Or your friend is still and you are moving. And here is the shocking part. You are all correct. Every single one of those answers is equally valid. There is no experiment you can perform, no measurement you can take that will tell you which one of you is really moving. Motion is not absolute, it is relative. Always. This sounds like a philosophical nicety, a technicality, something that does not really matter in practice. It matters more than anything else in this story. Now let's talk about light. In the late 1800s, physicists were trying to measure the speed of light relative to Earth's motion. The idea was simple. If you are on a moving train and you throw a ball forward, the ball moves faster relative to the ground than it would if you threw it while standing still. The ball's speed plus the train's speed, basic addition. So light should work the same way, right? If Earth is moving through space and you measure the speed of light going in the direction of Earth's motion, it should be a little faster. And if you measure it going against Earth's motion, it should be a little slower. They measured it very carefully, multiple times, different directions, different times of year as Earth moved around the Sun. The speed of light was identical every single time, in every single direction. It did not matter how fast Earth was moving. It did not matter which direction the light was going. The answer was always the same number, always. 299,792,458 meters per second. Exactly. This broke physics, not metaphorically, literally broke the existing understanding of how reality works. Because if the speed of light is the same for everyone, regardless of their motion, then the universe is doing something deeply strange to make that happen. And Einstein, sitting in a patent office in Switzerland in 1905, figured out what that strange thing was. If the speed of light is always the same, and if motion is relative, then something else has to give. Something else has to change to keep that number constant. That something else is time. Here's the key idea, and I want you to sit with this because it is genuinely one of the most beautiful and disturbing things in all of science. You are always moving through space-time at the speed of light. Not space, space-time. Einstein realized that space and time are not separate things. They are woven together into a single four-dimensional fabric. And everything in the universe is always moving through this fabric at exactly the speed of light. Always. No exceptions. But here is the twist. That motion is divided between space and time. If you are sitting completely still in space, all of your motion through space-time is going through time. You are aging at the maximum possible rate. Time is ticking as fast as it can for you. But if you start moving through space, some of that motion gets redirected. You are now spending some of your space-time speed on moving through space, which means you have less speed left over for moving through time. So time slows down for you. The faster you move through space, the slower you move through time. These two things are directly, mathematically, unavoidably connected. It is not a side effect. It is not an approximation. It is the fundamental structure of reality. Your total speed through space-time is always exactly the speed of light. You are always spending it somewhere. The question is just how you divide it between space and time. Let's make this concrete, because abstract is fine, but numbers make it real. Imagine a spaceship. It leaves Earth and travels to a star 10 light years away at 99% of the speed of light. From Earth's perspective, that journey takes a little over 10 years. You watch the ship leave, you wait 10 years, it arrives. But on the ship, the clocks tell a completely different story. Due to time dilation, the crew on that ship ages only about 1.4 years during the journey. While 10 years pass on Earth, less than a year and a half passes for the people on the ship. They did not cheat. They did not sleep through it. They did not experience anything unusual. Every second on that ship felt like a normal second to them. Their hearts beat normally. Their coffee got cold normally. Their hair grew normally. But fewer of those seconds passed because they were moving through space very fast. They were moving through time very slowly. Now push it further. Imagine the ship travels at 99.9999% of the speed of light. The same 10 light-year journey now takes the crew only about 5 days. 5 days of normal lived experience. Meanwhile, over 10 years pass on Earth. You leave Earth on a Monday. You arrive at a star 10 light years away the following Saturday. You turn around, come back at the same speed. You walk off the ship 2 weeks older. Everyone you left behind is 20 years older. This is not science fiction. This is not speculation. This is measured, tested, confirmed physics. We have done it with atomic clocks on airplanes. We have done it with particles and accelerators. GPS satellites have to correct for time dilation every single day, or the navigation system would drift by kilometers within hours. Time dilation is not theoretical. It is engineering. It is built into the technology you use right now. But now comes the question you should be asking. What happens at exactly the speed of light? If moving fast through space slows down your time, what happens when you reach maximum speed? When all of your space-time motion is going through space and none of it is going through time? Time stops. Not slows down a little, not almost stops, stops completely. A photon of light traveling at exactly the speed of light experiences 0 time between the moment it is emitted and the moment it is absorbed. From the photon's perspective, if it had one, no time passes at all, ever. A photon leaving a star 1 billion light years away and arriving at your eye right now experienced the journey as instantaneous. It did not wait 1 billion years. It did not age. It did not experience anything. It simply was at one place and then at another place with no time in between. This is why traveling at the speed of light does not age you. Because at the speed of light, there is no aging. There is no time. Time itself has been completely traded away for motion through space. You would not age because the very thing that drives aging, the flow of time, would have been redirected entirely into your motion. But of course you cannot actually reach the speed of light because you have mass. And as we discussed elsewhere, getting mass to light speed requires infinite energy. So this particular trick of timelessness is reserved for massless particles like photons. For everything with mass, time merely slows. It never stops. Now here is where it gets truly strange. Everything we have discussed so far, the time dilation, the way fast motion slows your clock, all of that has an equally bizarre partner. Space itself compresses. When you move very fast through space, space in the direction of your motion shrinks. The faster you go, the more it shrinks. At the speed of light, space in your direction of travel would compress to zero. This is called length contraction, and it is just as real as time dilation. So from the crew's perspective on that fast spaceship, they are not just experiencing time slowly. The distance between Earth and the star has physically shrunk. The journey is not 10 light years long for them. It is much shorter. That is why it takes less time. Not just because their time runs slow, but because the distance they have to cover has genuinely decreased. The universe literally rearranges its geometry around a fast-moving object. From outside, watching the ship, you see it moving very fast and its clocks running slow. From inside the ship, the crew sees themselves as stationary and the universe compressed in the direction of travel. Both perspectives are equally valid. Both are equally real. Neither is wrong. This is what Einstein meant by relativity. Not that everything is subjective, not that there is no truth, but that different observers moving at different speeds genuinely experience different versions of reality, and all of those versions are equally correct descriptions of the universe. Let's pause and think about what this means for your life right now. Right now, in this moment, there are billions of other observers in the universe moving at different speeds relative to you. And each of them is experiencing time at a slightly different rate. Each of them has a slightly different now. The concept of a single universal now, a single moment that everyone shares simultaneously, does not exist. It is an illusion created by the fact that we are all moving at roughly the same slow speeds on the surface of one planet. Two observers moving at different velocities will disagree about whether two events happened at the same time. Not because one of them made a mistake, not because their instruments were faulty, but because simultaneity is relative. There is no absolute before and after in the universe. There is only before and after from a particular reference frame. This is not philosophy. This is not interpretation. This is what the equations say and what experiments confirm. Your intuition insists there is a single universal clock ticking away, measuring out moments that everyone shares. There is not. There never was. The universe does not have one clock. Every object moving through it carries its own clock, and all those clocks run at different rates depending on how fast they are moving. So why does none of this feel real to us? Because we are moving so slowly. At everyday human speeds, time dilation exists. But it is so tiny, it is completely undetectable to human senses. A commercial airplane moves at about 900 kilometers per hour. At that speed, time dilation amounts to a few nanoseconds per hour. Your body cannot feel nanoseconds. Your brain cannot perceive nanoseconds, so you never notice. But the universe does not care whether you notice. It is happening right now. Your feet, slightly lower in Earth's gravitational field than your head, are aging very slightly more slowly than your head. This is real, measured, confirmed. At human scales, these effects are invisible. At relativistic speeds, they become impossible to ignore. At the speed of light, they become everything. Here is a thing that I want you to carry with you. Time is not a river flowing at a constant rate that everyone shares equally. Time is a dimension like space, and you move through it the same way you move through space. And just like you can slow down your movement through space by redirecting your energy elsewhere, you can slow down your movement through time by redirecting it into motion through space. The universe gave you a fixed budget, a speed limit that is always exactly 299,792,458 meters per second through space-time. You are always spending it. Every moment of your life, you are using it up. The only question is whether you are spending it on staying still and aging, or on moving fast and aging slowly. A photon spends all of it on motion, none on time. It does not age because it has traded every last bit of its space-time budget for speed. You spend almost all of it on time. You are nearly stationary on cosmic scales. You age at close to the maximum possible rate. And somewhere in between, there is a dial. Turn it toward speed, and you age slower. Turn it all the way to the limit, and you stop aging entirely. The universe is not keeping this from you. It is just showing you the price.